Today we're going to look at section 10-3, and I have really good news for you. A circle is tremendously easier to work with than a parabola. Although you'd studied parabolas before and haven't studied circles, you would think that maybe circles might be more difficult, and actually they're a lot easier, very much easier than they are a parabola. So, what is a circle? A circle is the set of all points in a plane. So we're staying in a plane. If we go to three-dimensional, we end up getting a sphere with this definition, if we take away the plane idea. So the set of all points in a plane that are a fixed distance from a fixed point. And the center of our circle is our fixed point, and we're going to label it HK, just like our vertex was HK in vertex form for a parabola. And the fixed distance that our points are going to be away is r. So, think about it. If I had a point who is my fixed point, and I call it hk, and if I want to be a fixed distance away from that, let's say I want to go out r. Say I want to go out r. I want to go out r. And I want every single point, even in between, I'll end up having a circle. Let's see how well I can do it. It's not too bad. Okay, so we would have that type of form in a plane, because if we went three-dimensional again, we would have a sphere. The set of all points in a plane who are the same distance, which we will call r, from a fixed point, which we'll call our center. So what's the equation look like? Well, it actually comes from our distance formula. And so on my graph, in fact, well, let's skip that one and go to this, because this shows up a little bit better without having the grid be quite so dark. If I take a fixed point, I'm going to put that point right there, and I'll say he is at HK. And if I want to be a certain distance away, and let's say this distance away is out here, and that distance is r. And let's say that's just a generic xy point. And if I want to find the set of all points x, y that have that condition of being the same distance away, my distance formula would say that the square root of the difference between these x-coordinates squared plus the difference between these y-coordinates would have to end up equaling that distance, which is going to be r everywhere. And now that's not the way the standard form, that should be an m in there, standard form for the equation of a circle. I need to square both sides, so I end up with x minus h quantity squared plus y minus k. I don't know why I'm going on an angle, but I am, equals r squared. There is the standard form for a circle. Okay, so now we're ready to write the equation of a circle. Write the equation of a circle who has a center at 3, 2, and has a radius of 3. And we could actually, again, draw the picture of it and think I have a circle at 1, 2, 3, 2. I want it to have its center there. And the center is not on the circle. It's in the center. And we want all points who are 3 units away. So I go 3 units down. I want 3 units over, 3 units over, 3 units up. I want to find all of those points. All of those points. Very easy. Plop my center right there. So x minus, get some more lead here, x minus 3 quantity squared plus y minus the y-coordinate, which in our case is 2, quantity squared, and that needs to equal r squared. Be careful not to just leave it as r, so I would have 9. I am done. There's my equation. Very easy to translate as well. Write an equation of the translation of this circle, and I need to go 2 units right, and I need to go 1 unit down. This circle has a center at 0, 0. I'm not subtracting anything away, and it would have a radius of 4. So that would actually be this circle. We'll just sketch it in. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So if we were going to graph that circle would look like that if Mrs. Easy could actually go around, and I didn't draw it very dark, I just dotted it in. But we want the graph to shift 2 to the right, and we want it to go 1 down. So we want the center to go from being at 0, 0 over 2 to the right and down 1. Very easy to do. X minus 2 will make it move right, squared. And I want it to go down 1. Y plus 1, quantity squared. And that needs to equal r squared, which is still going to stay as 16. And then that graph would have, here's the center, and I would move over 4, 1, 2, 3, 4. I would move up 4, 1, 2, 3, 4. Left 4, 1, 2, 3, 4. And down 4, 1, 2, 3, 4. And so if I were coordinated enough to make that distance stay the same, that's not too perfect, but that would be my new circle. Now, a couple more little questions on the other side. Oh, you know how to do this one. Find the center and radius of a circle with this equation. What's my center? -4, 2. Yeah. Figure out what makes this turn to 0. Boom. Figure out what makes that turn to 0. Boom. And my radius is, don't forget to square root it. Don't cut it in half. Square root it, 6. Graphing this circle, where's my center? Center's at 3, -1. My radius is 2. 3, -1. 1, 2, 3, -1. Boom, right there's my center. Now, he is really not on the circle, remember. And then I need a radius of 2, so I'm going to go right 2, left 2, down 2, and up 2. And then I'm going to try to go the same distance around. Not too bad. Okay, that was quick. Now you're ready to practice.